Catherine Breslin,
Hi.
welcome to Lingofest.
Thank you very much. Nice to be here.
Yeah, well, thank you for making the time. It's been a while, right? I think we saw each other multiple years ago, although we live in the virtual world, so we bump into each other virtually once in a while. All right, it's been a
Exactly.
while.
That's right. Yeah, it's been a few years since we bumped into each other in person. I guess there has been the pandemic in the meantime and the things that have preoccupied us, but
Yeah, I remember visiting you guys at Cambridge. Um, right? It was, and being impressed thoroughly by the team. I think that's where we met, right?
yeah, I think we met in Cambridge when you came over.
Yeah, and it
We were
was
both.
it was really an eye-opening experience in the sense that I think that group, or mainly, or most of the group, came from the EV acquisition. Is that what it's called, right?
Yeah,
Natural language. Yeah.
yeah, that's right.
And so it was a tight group, meaning it had its own culture and all that. And I loved how close and focused you guys were in what you were doing. So I definitely enjoyed that stay. I still remember it fondly. Um, so well, since then, lots of things have happened. Um, Amazingly, I think we are in the 8th year of the Echo's birth, aren't we?
Yeah, it was launched in 2014. I remember it was just a few months after I joined Amazon. It launched in the US and then, here in the UK a year later.
Yeah, yeah. But time flies, doesn't it? 8 years later. But let's touch on the many things that you've done since then. I'm sure the latest thing you're doing is probably like me. The latest thing I'm doing is always the most exciting thing,
That's right. Yeah.
right? Maybe we can start talking about that. Do you want to talk about the King Fisher Labs? I wanna really because I first of all I love that name, Kingfisher Lab.
Thank you.
But maybe you can start with that. Is that okay?
Sure. So I I founded Kingfisher Labs about a year and a half ago now because, well, it's nice to sort of work freelance and to work with lots of different companies. I think that's what I was interested to do. So I founded Kingfisher Labs, just with the goal of, working with different companies here in the UK and Europe who are trying to use voice and language technology in their products and their services and really needing some help and some guidance and some experience to figure out how to do it. Obviously started in the middle of the pandemic, so there's a lot of juggling homeschooling and business alongside each other in the beginning. And because I don't know about you guys, but we had a lot of time when the schools were shut and kids were home, and lots of different things were going on. But still, it's been a year and a half now, and I'm excited to work with a few different clients that do very different, very exciting things, I think.
Yeah, yeah. If you were to pick if you were to pick one problem that you have solved or have been working on, that you think is really interesting, both in terms its technical challenge as well as in terms of the value that that solving it would deliver.
Hmm.
What would your answer be to that?
Oh gosh, that's a tricky question because there's so many different areas and applications that you can use this technology in. I think one of the interesting things about voice and language technology is that the core technology is not specific to any one problem or any one domain. So you can build a speech recognition system that works in a legal transcription product, and then the same technology can be used in a healthcare setting, or the same technology can be used in a financial setting. And so I really like the fact that you get to work on lots of different application areas, but bring your knowledge of the core technology to people who have that domain expertise, that you can work with them and figure out how to work together. I think there's been so many advances in speech and language technology over particularly the past decade, because the surge in, I probably heard of deep learning and neural networks and how they have changed AI and machine learning in the past decade. And they have done in speech too. And we've managed to build voice recognition systems that are a lot more accurate, that can deal with a lot more kind of language. But one thing I think where there has been work in this area, but hasn't really all come together yet, is the combination of sort of voice recognition with NLP technology. So there's technology where you can sort of have speech recognition and get a transcript of what you said. But if you want to search that transcript or understand what was happening in that speech, it's quite difficult.
Mm-hmm.
There's, on the other hand, NLP technology, which works with text in order to,
Mm-hmm.
you know, take some text and do various different interesting things with it. But I think this combination of the two, you know, using or spoken language understanding, you know, to pull the two together is a really interesting area right now.
Yeah. Yeah, I think the separation, right? Separation between processing a signal and turning it into words, and then processing the words and turning them into meaning. I think that separation is artificial, right? In a way.
A little
Yeah,
artificial, but you can see why it's come
yeah,
up, because these are big technologies to build. And
exactly. No, that's exactly
yeah,
right. I mean, it's really hard, right? I mean, that's the easiest way to proceed, meaning, solve the problem of speech independently, more or less, of the so is what you're saying, in essence, that the next challenge, or the current challenge really, is to figure out a way to, as we are processing what somebody's saying, that we use both the NLP, I mean the natural language model, as well as the speech, the speech acoustics and all that, so that we can come up with a correct transcription that lends itself to, a parsing of meaning, that is less prone to error than otherwise.
it's not the only challenge, but I think it's certainly one of the interesting ones. You can imagine that when you speak, for example, we don't speak always in the same way that we write. A long time ago, when I was working back at Toshiba as one of my first jobs after my PhD, we built a system which could transcribe meetings.
Mm-hmm.
This was a task that the speech recognition community were working on at the time, and there was a data set released from Sheffield University of people in meetings, and we tried to transcribe them. And one thing I realized from working on that project is that if you take just the transcription of a meeting where people have been having free-form discussions and there's not so much structure, it can be really difficult to read after the fact. People change what they're thinking halfway through. They go back and forth. They meander a lot, and decisions get made
Mm-hmm.
sometimes by the body language of people in the room. So you can't understand just from the transcription of a meeting, what actually happened in that meeting sometimes. Um, so that task of taking, meaning and information out of those sort of free-form conversations is definitely interesting and challenging.
Yeah, yeah, interesting. Yeah, and the interesting thing is, during that conversation, right, everybody knew what was going on, right, right, because
Yeah.
the signals were there and all that. But then the flat transcription loses all of that context, right?
Mm-hmm.
And so, just to sort of double click, so to speak, on that problem, um, let's say somebody wants to take that, and render something that would be useful to someone. Let's say a
Yep.
summary of that meeting. Um, a human being would, let's say somebody would be tasked with that, and say, hey, can you basically write, I don't know, a summary of what happened?
Mm.
And I guess they would basically come up with like the main points, the main action items, and all that,
Yep.
right? Is there technology that does that today, or something like that, that takes flat, as you describe it, as I describe it, but the flat, the transcript, and convert it into something that's usable?
I think people have tried things in that direction, and this depends a lot on the type of recording that you're listening to. So people talk in different ways depending on the
Yeah,
context.
yeah, yeah.
If you're giving a lecture, for example, and you're standing giving a talk in front of lots of people, you want to be very clear, and you're keeping a consistent train of thought, and you're often speaking a little more grammatically sort of much more like written language than you might be like spoken language. And summarizing lectures or finding action points, or points of interest in lectures might be an easier challenge than summarizing, a meeting where people are designing and brainstorming and coming up
Yeah.
with new ideas, because there's a lot of talking back and forth and half-finished sentences and different thoughts in there. So partly it depends on the difficulty as well, depending on the style of the thing that you're trying to transcribe.
Yeah. Yeah. And I was just thinking that I think it would be hard for a human being who was not in the meeting to take a flatly transcribed that meeting. Let's say they are conversant with the, with the character, with the people, as well as the domain.
Mm,
I think even then it would be hard for them to necessarily turn it into something as tight as it. Not meaning, what I mean is maybe they need being there and observing and getting a sense of the mood and
yep.
getting a sense of what is important, what is not important, what is a tangential, what is not, um, which are all cues that are beyond, I think, pure words, right? They are visual, also tone, power, relations between the
Yep.
people, and all of that. So yeah, I think
Yeah, a lot of that gets missed when you just convert it to a transcription. And I think it can also be difficult if you've got technical topics that you're discussing in a meeting as well, very specific vocabulary that people might not be familiar with, very specific problems. All of those can add to making it challenging.
yeah. No, I just wanted to give the folks who are watching and listening a bit of a sense of
Yeah,
how quickly it devolves into a complex problem.
yeah,
Um, Although the business value is very clear there, right? Take an audio. I guess let me just continue with one more step, which is if we were to feed the audio, right, not just transcribe, but the full audio, and the task is not to simply transcribe, but to come up with that summary. I think there you would include lots of, I mean, you would find a lot of those cues, perhaps minus the visual. And then the last one would be, what if you could have an AI listen and observe
mm,
and then come up with a list of actions and so on and so forth. Anyway, so let me ask you the next question here, which is something that I have in mind and keep thinking about, and I'm not making a lot of progress as far as thinking things through. So whenever I have an opportunity to engage with the brain that has thought about these matters, sort of jump on it. So this is the problem of, let's call it conversational turn and pointing, knowing the end of a turn.
mm.
Like human beings, we are really good at it, right?
Yep, we are.
So when I'm talking, I could pause, and you wouldn't think that I have finished because maybe I'm in the middle of a thought, maybe the intonation is such that that I still want to retain the tone and so on. Um, so as we were talking at the beginning, right? So this is the 8th year, right, of the Amazon Echo. I don't know if it was recorded or it was before. Um, like this is the 8th year of the birth of the Echo, right? And for me, it sort of amazes me that the assistant is still pretty bad about determining when you finish talking. What are your thoughts about that? Why is it so hard?
It is a really hard problem to decide them. So, and like you say, we're really good. We don't converse in a very strict format, and a conversation is a little bit like a collaboration between the two of us. You leave gaps in your conversation, or come to a point where it might be natural for someone else to take over, and you see if they do, and if they don't, you carry on. Otherwise, you let them, and it sort of evolves in this collaborative kind of way. There's a lot of cues that we use to signal that we might be coming to a point where someone can interrupt. And there might be points where, people decide to interrupt and just go ahead anyway, like without being allowed. So there's whole areas of linguistics looking into how people like give and hold the conversational floor in a conversation called the conversational floor. So if I give the floor to you, I might indicate that I want you to start talking by looking at you, for example. I think that's one way that you can pass the floor. But what's really interesting about conversation is it happens really quickly. You know, we often the the time between you finishing talking and me starting talking is really quite quick. It's like maybe less than 200 milliseconds. It's 0.2 of a second. But our brains actually haven't got enough context to be able to make that prediction. That's not enough time for us to think about it. It takes us actually longer to start talking than 200 milliseconds. So we have started to predict our turn while you're finishing yours. So computers at the moment actually don't particularly do this sort of prediction of when they can come in and interrupt a conversation. They tend to wait for a pause in the conversation. And then once there's been enough silence, they can interrupt and say, but that takes longer than this 200 milliseconds. And we're heavily attuned to even small differences in this. So it might take a voice assistant, half a second or a second to come back. But to us, that seems really long compared to this 200 millisecond roughly that people can do it in. And people sometimes, talk over the end of each other. 200 milliseconds is an average. Sometimes you'll start talking even before the other person has finished talking. And there's lots of cues that feed into this. So things like eye gaze, gestures, like you say, if you're going to continue talking, you might indicate that by the way you say it, the intonation, or you might indicate it by stopping in the middle of a sentence on a word that clearly isn't the end of what you were saying. And all these things are just very fiddly and complicated to get into a computer right now.
Yeah. Well, let me double click again, because I think there are. Hang on, let me just Skype. I'll quit it. Sorry about that.
Okay.
So, for example, right? I think today it feels to me, and I may be wrong, that the main way that, say, Google Assistant or Amazon Echo, the main way that they detect that you're done is silence, right?
So I can't say particularly about how Alexa works now or
Yeah,
how
yeah,
Google works now, but I have built systems in the past that are based on silence.
silence, right?
Right.
But it feels to me that perhaps bringing in the NLP, perhaps knowing that somebody is in the middle of a sentence, and that perhaps that pause is not a turn seeding action, but rather simply pausing to think about what to say next, right? And I'm seeing Google being more forgiving there, meaning they sometimes I can pause. Let's say I want to recall the name of a song or something that I'm asking for, and I may say, and then I come up with it.
Yeah.
Right? Whereas the Echo is less forgiving, perhaps. I don't know. It's just perception. But it seems to me that that's one perhaps low-hanging fruit cue, which is the natural language, right? Or have they finished something that seems to be either a phrase that is a thought? I don't know. Maybe that's a tough one as well. Have they completed a thought, perhaps, or have they completed a sentence? Right? And what is a thought and what is a sentence? And not a sentence in the grammatical sense, because we rarely speak necessarily in fully grammatical, right, ways. But what do you think? Are there low-hanging fruits like intonation? So intonation is used quite a bit. I can tell without even listening to the words whether somebody is finishing a turn or starting, or right. And I think we have enough data, it seems to me, enough audio to say, okay, here are examples where they paused and didn't want to give it a turn. Examples, blah, blah, blah. So that's why I remain mystified, because I feel there are a few low-hanging fruits. And again, you know how to reveal anything. I just want to talk in terms of concept.
Yeah, no, obviously there are things that you could use, and there's a trade-off as well. So if you interrupt somebody when they haven't finished talking, then just for the sake of trying to respond quicker, but you keep interrupting them, they'll get frustrated much more than if you leave it slightly too long at the end of a sentence. So there's this trade-off in that you actually would prefer to leave it slightly longer to avoid frustrating some of your users on a voice assistant. So that's one consideration. It's not a balanced judgment call about which way to lean on that decision. Some people I know have tried to use natural language. So you can tell, for example, whether somebody has completed something which is understandable by the assistant. So if you were to say, play me some music, and then pause, that play me some music is completely interpretable as a command. Whereas if you say, play me and pause, there isn't enough there to tell you, so you might want to wait longer. But then you could be pausing and say, play me some music by somebody. And there's a risk that you interrupt there. So it's not entirely infallible that you can use the NLU, because sometimes people have longer thoughts. You can, I think, predict some of this from intonation as well, but intonation is not always reliable because it varies from person to person and from culture to culture as well. So there's different factors in there. I think when studies have been done on this sort of which signals contribute to the end of turn taking, there's no one signal that dominates. The people are very good at taking in signals from multiple different places and deciding which ones to pay attention to at a particular time. And our computers run the risk of, if you only try to take into account one signal in shrinking that time to respond, you end up interrupting too often and not doing a good job.
Yeah. Well, I mean, I think it's difficult and maybe almost intractable if one were to build something algorithmic. But if one were to just feed the beast lots and lots of data,
Yep.
and tag it and say, this one they finished, this one they didn't finish, and let's say you're just trying to solve the problem of a pause. Maybe, I don't know, maybe that could get us a little bit closer to where we want to be. Perhaps.
And there is some interesting academic research in this area as well. So, hopefully that will come to fruition sometime soon and be able to be brought into some of the products we use.
Yeah. And the reason why I'm harping on it is because I think it's one of the biggest problems for adoption out there, especially for older folks who would benefit the most using this technology. I work with, for example, I work with ARP Foundation. This is an organization here in the United States that looks after it's an organization that takes care of issues and causes for all seniors, right? So retirement and all kinds of issues. They have two branches. One is nonprofit and one is sort of politically involved. Anyway, I work with the nonprofit one, and I do a lot of field work out there. We build skills and so on for the seniors, right? Seniors, 60, 70, 80, 90, right? These are folks who who surprisingly were very open to adopting this technology, right? Because usually as older you get, the more conservative, like, okay, I've lived so far with X, Y, and Z, don't add A, B, and C to my plate, right? But they, I mean, they are embracing this technology quite a bit, but it's frustrating to see them being frustrated by this issue, because we all slow down as we get older.
Yep.
Of life, right? And we all need a little bit more time, get a little bit slower, so to speak. All right. And so yeah. And so I think it's not just a nice to have in a way, right? I think it's a big problem. And the sad thing is, because they think that they are behind the times, they blame themselves. They say, oh, it's my fault.
Yep, I've seen that, when people blame themselves for technology's flaws.
Right. The older you get, for some reason, the more you want to take the blame, because you say, oh, these old young people and so on and so forth, they're doing things and I'm just way behind, which is absolutely not true, in the sense that it's the technology's fault. Obviously, I'm saying something that's obvious. I don't understand why this thing keeps interrupting me. Okay. Wonderful. So would you characterize yourself as a speech scientist or as a natural language understanding person? If I were to sort of like ask you point blank, pick one. I know.
If I had to pick one, I would probably choose speech scientist of the two. I spent most of my career working on voice recognition and voice assistants as well. So a lot of the technology, even when I've used NLP and language technology, has been in the context of some voice applications. So probably I think that classes me as a speech scientist.
Okay, okay. And so what kind of problems do speech scientists solve? I'm sure our audience wants to know. Some folks who are in the audience have never heard of a speech scientist. So I assume
Yep.
that's the person we're addressing.
So I guess one of the obvious things that speech scientists work on is speech recognition technology. So that's taking audio and transcribing it automatically. And the technology is forever improving, so there's always new things to try and new applications that you're trying to use it in that you want to train systems to work in. So training the speech recognition system for something like Alexa or Google Home is a very different, slightly different task of training something that a doctor is going to use on their daily rounds, or training something that's going to be embedded into your smartphone for dictation. So there's all sorts of different language and different styles of speech that go into those. So that's one thing you can do. You mentioned just now about, finding the end of a piece of speech. So that's another, is, helping to make that turn taking in conversations a little bit better, and process the speech, figure out who is speaking and when they're speaking, those sorts of problems. And on the flip side of that, you've got speech synthesis, so speaking out loud. And that is a really interesting area as well, because we've got, quite natural sounding synthesized voices now, but they need a little bit more expressivity in them, a bit more of an injection of sort of emotion and style. And so there are some challenges in how to build speech synthesis voices that can, perform in a variety of different applications. And then I think another thing that is really valuable is trying to figure out, exactly which of this vast range of speech technologies, exactly which is applicable in which particular application that you want to build. So having that conversation and discussion, and trying to get from, business requirements down to some sort of technical specification of what to build. So I hope that gives a flavor of a few of the things that people
Yeah,
work on.
absolutely. Yeah. I'm also thinking of like voice biometrics, right?
Yeah.
Extracting emotion perhaps from audio, and then identifying people, right?
Yeah, so figuring out who is speaking is one. People have looked into, I don't like talking about emotion detection, because you can't really understand someone's internal state from how they talk, but you can understand perhaps if they're frustrated and you need to do something differently, or you can know if they need to escalate. Like if you're building a call center technology and someone is frustrated on the phone, or angry or annoyed in some other way, you might want to take action and do something with that information. So there's definitely sort of understanding sentiment and mood that is interesting.
Yeah, yeah. Okay. And then let's talk about very quickly, then what does a natural language expert do, um, as opposed to a speech scientist?
So the world of NLP, or natural language processing, has also had a bit of a boom lately. One place it intersects with speech science is in a voice assistant. You have to be able to, once you've understood what someone has said in terms of the words that they've said to the assistant, so they've said play some music, you have to decide what to do with that. So that's taking the text of the transcription and categorizing it into one of the things that the assistant can do. So they might say, play me some music, or I want to hear some music, or music now. And all of those should lead to the same action. So you're trying to categorize what the user said into an intent, essentially. But if they say, I want the weather forecast, that's a different intent. That's a different category text. You also try and extract entities or slots from what they've said. So if they say, play me music by Madonna, you want to pick out the Madonna so you can play the right music. Or if they say, give me the weather in London, you need to know what city, London, they're talking about. So those two tasks, sort of intent recognition and slot recognition, are two that are used in virtual assistants. But then beyond those technologies get used on written text for lots of different purposes as well. So text classification, taking a bit of text and classifying it, is a common task that people do, as is, identifying named entities in the text, or translating from one language to another is another NLP task. And there's a whole bunch of other tasks. I could probably list a few more out, but anything where you can think of some structured thing you want to do with a piece of text, you can think about trying to build an NLP system to do that.
Yeah. One that fascinates me is creation of content. Let's say news stories, right? And I think it's being used out there for by local newspapers or local websites where reporting on accidents, reporting on weather, reporting on that, and giving you sort of something that is narratively constructed so that you can read it as a story, which doesn't require a human being necessarily. And then we get into, of course, all the interesting issues of, okay, what does that mean for us human beings and the folks who start their career there. They write little stories that are easy to write, so to speak, so they get the wheels going, so that they can then be investigative reports and all that. So what are we losing? So all of that, all of this automation, these automation issues have been around for a long time, obviously. But now I think they're starting to grab attention because they are starting to trespass, so to speak, into the let's call it the white collar, the white collar world, labor. And so when when a reporter no longer can do that, and there's machine, then there's more of an outcry than folks who are less involved in, say, in the political system, all that. Anyway, so this is one of those fascinating things that I think the nature of the technology, and what it can do now gets us into automating something that is not manual, but it's something that's intellectual.